Hey everyone, I'm Kumar. The title of our project is An Innovation of Modeling and Simulation for Internal Combustion Engine for Bus Kita Plug-in Hybrid Electric Bus. Aim of our study is to reduce emission and fuel usage of vehicles. The objectives are to determine parameters and specification of ICE for Bus Kita PHEB and to derive a model of ICE Bus Kita PHEB in MATLAB and simulating environment and to verify and analyze Bus Kita PHEB ICE using advisor.
Have you ever wondered what is air quality index and also why the price of the fossil fuel in our country keeps spiking from time to time? Air quality index is a scale which measures the air pollution level which may affect a person's life within a short period of time. And also the price of the fossil fuel in our country keeps spiking from time to time due to its higher demand by our country. Fossil fuel in our country are majorly used for transportation sector. Vehicle which uses petrol and diesel for propel the vehicle emits a lot of emission such as nitrogen oxide, carbon monoxide and also particulate matter. In the year 2005, Malaysia has been declared as a moderately unsafe country because the air pollution level is quite high. To overcome the problems simultaneously, Malaysian government has come out with a lot of strategies. One of them is using public transportation. One of the most common and favorite public transportation in Malaysia is public bus. Similarly, in Kuala Terengganu, a bus named Bus Kita, which is owned by Charles Liga Sendirian Berhad, is the most favorite public transportation among the residents. Almost 57,314 passengers using Bus Kita for their daily travelling. Their charges ranges from Ringgit Malaysia 1 to Ringgit Malaysia 5, which covers 16 hotspot places in Kuala Terengganu and also extra facilities such as air condition and also charging plugs make the bus more favorite among the residents. Although public transportation has been successfully implemented in Kuala Terengganu, air pollution and also fuel usage still getting worse. It is proven when, according to Charles Liga Sendirian Berhad, the amount spending on diesel increased by a year around 317,054 ringgit Malaysia, where the cost was in the year 2016 it was 144,515 ringgit Malaysia, while in the year 2017 the cost was 176,273 ringgit Malaysia. On the other hand, the concentration of particulate matter at Kuala Terengganu has also increased significantly around 4%, while in the year 2001 the concentration of particulate matter was 50%, where in the year 2010 it was increased about 4%, resulting in 54%. Emission and fuel usage from Bus Kita cannot be controlled because it solely depends on combustion ignition internal combustion engine. To overcome this, manufacturers has introduced new vehicle topology where hybrid electric vehicles are introduced to replace traditional internal combustion engine based vehicles. Hybrid electric vehicles can be operated using electricity and also fuel to propel the vehicle. Similarly, Bus Kita plug-in hybrid electric bus is introduced in Kuala Terengganu. Bus Kita plug-in hybrid electric bus consists of electric machine, energy storage system and also internal combustion engine. Internal combustion engine is the only component using fuel in the entire system. And also, internal combustion engine only used during rapid acceleration and also when the state of charge of the battery is fully depleted.
Methodology for this study involves three steps. They are: first, to determine the parameters and specification of ICE and for Bus Kita PHEB. Second, to design a model of ICE components using MATLAB and simulating environment. Third, to validate and analyze the internal combustion engine with advisor. To find the power requirement, Bus Kita specification and parameters are required. Specification and parameters of Bus Kita were obtained from Charles Liga Sendirian Berhad. The parameters and specification of Bus Kita were substituted into this equation to determine the power requirement of Bus Kita. Referring to the component sizing of Bus Kita PHEB, the electric machine requires 356.66 kW of power at the peak acceleration of 60 km per hour and the highest gradient of load, which is 5%. The internal combustion engine requires 158.38 kW of power. The energy storage system requires 87.75 kW of power. The input for the ICE model in MATLAB are speed and torque, while the outputs are efficiency, fuel usage and emission of hydrocarbon, carbon monoxide and nitrogen oxide. This is the model of internal combustion engine for Bus Kita PHEB built using MATLAB simulating environment. Third step in this study is validation of ICE using advisor in terms of output efficiency, fuel usage, emission of hydrocarbon, carbon monoxide and nitrogen oxide. Once the model is developed, the next stage construct a closed loop system, the PI controller used in a way that power of ICE can be controlled according to load demand. In this study, genetic algorithm and PI controller usage together when optimize the model. Thus, in optimization, the initial population of the PI parameter is chosen by trial and error method. Then, the tuning of controller using genetic algorithm is carried out with genetic algorithm parameters. The input for ICE model are power and speed. The data of power and speed were obtained from Kuala Terengganu driving cycle. From the simulation, the efficiency, fuel use, and emission of hydrocarbon, carbon monoxide, and nitrogen oxide are obtained and compared with conventional vehicles. From the comparison, it is proven that bus Kita PHEB are able to reduce emission of hydrocarbon, carbon monoxide, and nitrogen oxide. Bus Kita PHEB uses less fuel to travel the same distance as conventional vehicle, but it can save about 33% and 53% annually for low and high density traffic pattern type cycles respectively compared to conventional vehicles. Also, bus Kita is more suitable for city driving cycle where the traffic is moving slow and there are more opportunity to recover the regenerative braking energy during stop and start events, and most of the energy used to move the vehicle comes from the power grid where it is a lot cheaper compared to the fuel price.
First plug-in hybrid electric bus in Malaysia. Similarly, at Johor in the year of 2017, Hino hybrid bus was launched. The difference between these two buses is energy storage system. Bus Kita consists of larger energy storage system which can travel up to 70 km in all electric range mode, while Bus Hino can't since it is hybrid bus, not plug-in hybrid electric bus. Second, able to reduce air pollution by controlling emission from vehicle. Bus Kita use lesser fuel than other vehicles. Internal combustion engine is only used during rapid acceleration and when the charge of the battery fully depleted. Third, able to reduce fuel usage. Since Bus Kita can travel up to 70 km just in all electric range, the fuel usage is lesser than other vehicles. Fourth, internal combustion engine for Bus Kita has good commercial potential in market because it use lesser fuel and reduce emission at the same time.